This lesson we're going to look at solving higher order polynomial equations. So when we say higher order, we mean that the exponent, the biggest exponent is either going to be cubed to the fourth power or higher. Last unit we really worked on solving quadratic equations where the biggest exponent was 2, and in the first unit we did a little bit with linear equations where the biggest exponent was x to the first. This one right here actually requires pretty advanced factoring techniques, ones we won't solve, but what we're going to use today is basically techniques we already know and then just a little extension of something else. So first question we have is, what is the maximum number of solutions for a linear equation? And if you remember when you solved equations in unit 1, like 5x plus 2 equals 7, we had distributive property. It was a little harder than that, but we only had one solution. When we started quadratic equations, we expected 2 solutions, and we also knew that we always got 2 solutions. Sometimes it was a double root, so we had 2 solutions that were equal, but there were 2 solutions. And this continues, cubic equations x cubed. We expect 3 solutions, and in general, how would you generalize the maximum number of solutions for a polynomial equation? Basically, the max number equals the biggest exponent. So here I'm just going to kind of look through some of the different methods we're going to use. This is already written out, but we will obviously in the video also be doing examples with these. So the first one is if you have some sort of GCF. So it kind of looks like it's, higher order, but once you take out a GCF, you really only have to work with a quadratic. So here's an example. As usual, when we're factoring, we're going to solve these with factoring. We set it equal to 0, so I brought over these 2 terms. We're keeping the lead coefficient positive, like we talked about last unit. So the GCF here is 5x cubed. I take that out. And then I factor. This is just basically what adds up to 4 and multiplies to 3 is positive 3, positive 1. Now looking through these answers, this is split up. You could just write, I would write 5x cubed equals 0 here. And then when you solve it, you divide by 5, you cube root it. Basically, we said whenever we have a monomial factor, that always gives us an answer of 0. This one gives me negative 3, and this one gives me negative 1. Now, this was x to the 5th, so I was expecting to get 5 different answers, but this section here, x cubed, really gives me 3 different answers of 0, and we'll talk more about what those look like in the graphing lesson we do, but an idea is that there are really like 3 equal answers of 0 right there, making a total of 5 if we count 3 zeros. So looking at the next one, this one's it's kind of new, and I'm going to move this over and actually write some stuff. You could write it below when you do yours. So here is a quartic equation. That's our name for x to the 4th. I set it equal to 0. Now this is actually structured like a quadratic. So if I write x squared minus 13x plus 36 over here, let's just clean up that x squared. If I was factoring this and trying to find numbers that add and multiply, I would factor that with negative 9 and negative 4, right? Not too bad. So here, when we have a 4th power and we have a squared in our middle term, we actually can factor it the same way but put x squareds in the front. Now if I distributed this, right, if I multiplied this out, I would get x to the 4th. That works. I would get minus 4x squared and minus 9x squared, which would be negative 13x squared, and then I get positive 36. So it's like factoring a quadratic, but we just put x squareds in the front of our binomials. From here I'll solve. Now in this particular problem, once I get this factor, the x squared minus 9 equal to 0, I could factor that more, but I could also use incomplete quadratics. So we just added the 9 over, take a square root, and we get plus or minus 3. Same deal over here, move it over, take a square root, get plus or minus 2. So this one we did get 1, 2, 3, 4 answers, which is what we are expecting for a quartic equation. Looking at the next page, here we have our last one, and this one is one we did a ton of last unit. We just didn't really do solving with it. So this is our 4 terms. We see an x cubed, right? So we're expecting some sort of, 3 answers here, not some sort of, we're expecting 3 answers here, and we just group it, right? Group it up. Then we get to this point, we have 5x squared times x plus 3 minus 2 times x plus 3. We take out the common factor of x plus 3. Usually we'd write it in the front. I have it in the back for some reason here. Now at this point, and this is, we'll see a lot in these equations, now I have incomplete quadratics. So I actually can't factor further here, but even so, just like the last one, once I get to those 2 terms, I can just solve using square roots. So on this one, this factor, this one's a little tricky. I move over, add 2, divide by 5, and I get to here. When I take a square root, I have to split up that radical, right? So I have plus or minus radical 2 over radical 5. Here we're rationalizing the denominator, multiplying by radical 5 over radical 5. That gets rid of the radical in the denominator, and we have radical 10 in the numerator. This one, nice and easy, linear, get 1 answer. So my answers here are -3, negative radical 10 over 5, and radical 10 over 5. Now this next part just kind of gives us an awareness that these are graphs and they would have intersections with the x-axis that still correspond to where the functions are equal to 0. So if I went back to the last page, my solutions were x equals 0, right? X equals -1, and x equals -3. And that would be that if I graphed this x to the 5th equation, I would see that it crossed at those locations. The next one, on this one, I had -3, -2, 2, and 3. Those were my answers. If I looked back at that previous page, those are where it would cross. Basically, it would come through and go like this, just to kind of go with that last unit. And that's not perfect, but basically it would cross at those 4 locations. This one's a little trickier. I would basically just have to type these numbers in my calculator to find exactly where it crossed. These are real numbers, so it does actually cross, but it is going to have a decimal value. To the nearest 10th, radical 10 over 5 is 0.6, and that's what it says to round to here. So my answers would be the -3. It would also cross at -0.6 approximately, and then positive 0.6. So we're going to look at 2 of the actual problems now and try them fully through. So we have this first one, x to the 5th. Now this one, and as always with all factoring, we look for a GCF. It does have a GCF of t. So I'm going to take out the t, and that leaves me with t to the 4th minus 10t squared plus 21. This equation here is that structure where we have a 4th power, a squared, and a constant. So I'm going to factor it like a quadratic, but I'm going to put t squareds in the front instead of just a t. Numbers that add up to -10 and multiply to 21 are -7 and -3. And we'll put the t in the front. Okay, so from here, we have t equals 0, right? When I set this one equal to 0, I just get t equals 0. This one, I get t squared, I'm going to move it over, equals 7. So when I take the square root, I'm going to get plus or minus the square root of 7. And this one, I'm going to get t squared equals 3. So when I take a square root, I am going to get plus or minus square root of 3. So when I look at this, I have 1, 2, 3, 4, 5 answers. If I wrote them in the brackets, I have negative radical 7. I'm going to write them in order, it doesn't matter, in terms of largest to smallest. And then these are my 5 different answers. The last one is grouping. So whenever I see those 4 terms, we still just group. So I have a squared times a plus 3 and -1 times a plus 3. So I have a plus 3 times a squared minus 1. So this linear factor is going to give me an answer of negative 3. This one, I'm going to move the 1 over so I get a squared equals 1, take a square root, and I remember my plus or minus, so plus or minus 1. So we have negative 3, negative 1, positive 1 matches up with those three solutions I expect because it's an x cubed equation.